Hi friends, welcome to follow-up. In this video and several follow-up videos, we are going to introduce some concepts from graph theory. So this concept can be relevant to a number of LeetCode problems. So in this video, we are going to look at problem 1535, find the winner of an array game. So our plan will be the following. First, we are going to digest the problem requirements, and then we look at the logic, and finally we share the code. So the concept we're going to introduce in this video is the indegree. So with that said, let's look at the problem statement. So here we are given an integer array of distinct integers and an integer key. So we are going to play a game. So in each round, we're going to compare the first two elements in the array. The larger integer wins and remain at position 0, and the smaller integer moves to the end of the array. So the game ends with when an integer wins k consecutive rounds. So we want to return the integer which will win the game. So here it's guaranteed that there will be a winner of the game. So actually, the last paragraph also helps us to write code in a neat way. In other words, so there is always a solution will be important. We'll emphasize this point later after we finish the coding. So another point I want to mention is that the game ends when an integer wins k consecutive rounds. So actually, due to the assumption that the array contains distinct integers, if an integer begins to win, it will win consecutive times, or it will win a certain number of consecutive rounds. So in other words, we don't need to worry about this consecutive requirements. So here we have two examples. In the first example, the output is 5. So here is an explanation. And in the second example, the output is 3. So here, if you compare, you see that the array has length 3 and the key has a value 10. And also 3 is the largest number. It's already in the beginning, right? So we're going to comment on this. So another thing I want to mention is that the constraints. First, the array can be as long as 10 to the power 5. But this number is a decent large number. But for a typical machine, so it can treat 10 to the power 7 operations per second. So if you have practiced a large number of LeetCode problems, so if you have a linear time solution of n, so n is like 10 to the power 5, so it's quite possible that you will pass all the test cases. However, if you look at k is 10 to the power 9. If you have an algorithm of O of k, it's quite possible that you cannot pass all the test cases. So with that said, let's look at the strategy. So here I'm going to explain a very verbose or simple simulation. So the main observation for this problem is the following. So after n-1 comparisons, the max of the array will always be in the beginning. So this observation actually is very simple, right? So but due to this main observation, if nothing returns after we do n-1 comparisons, where n is the length again, so we just need to return the max element due to the assumption that it's guaranteed there will be a winner of the game. So in this video or in this problem, the concept comes into play is the indegree for a directed graph node. So here, let's see, we use capital G and V of E to represent a graph. So V is the set of vertices and the E is the set of edges. So the indegree of a node in a directed graph is the directed edges pointing to the node. For example, if you have two directed edges pointing to a node, that node will have indegree 2, right? So with that said, we are ready to do the coding. So the solution will be O of n. N is the length of this array. So in the time complexity part, the key is sort of dummy if key is very large. So it's larger than the length of this array. So here first I'm going to introduce a dictionary. So collections default dict. So I'm going to use int. So this dictionary will store the element or the number and then the consecutive wins. The number of consecutive wins. Actually, we don't need to emphasize consecutive because of the assumption that the array contains distinct integers, right? So with that done, I also want to make a deck out of this array. So this is just for convenience, or I want to use this pop left method of the deck object. So with that said, we are ready to do the coding, the main logic part. So I'm going to use a dummy index. For this dummy index in range length array -1, we just need to use m-1 times for comparison. So if, let's first make some simple treatment. If deck 0 is greater than deck 1, so in other words, the larger one is at the height. So I'm going to swap these two. So I'm going to copy this part, and then I will change this to be 0, 1, and this one to be 1, 0, right? So after this if block, so the first element or the head element in the deck will be the smaller one. Then we can update the counting for consecutive wins, right? So this means the deck 1 is incremented by 1. So here we don't need to check if deck 1 as a key is inside D or not because of the default dictionary, right? This brings us some convenience or save one line of coding. So also we need to check if we need to return, right? If this frequency equals key, so we just need to return deck 1, right? So the main operation for this simulation is that we want to put the smaller one to the end of this queue or deck. So what I want to do is deck append. So deck pop left, right? That's the reason that here we are using a deck. So with that done, so if nothing returned, so because it's guaranteed that there will be a winner for the game, and after n-1 comparisons, the maximum element of the array is always at the beginning of this array. So it will be the winner for sure afterwards if k is large. So we're going to return deck 0. So with that said, we are finishing the coding part. Now let's do a test. Yeah, it passes the second example. Actually, here I changed the key to be a large number, but and also I changed 2 and 3 in position to avoid that the maximum will be at the beginning as we're at the default, right? So now let's look at the generic case. Yeah, it passes all the generic cases. So with that said, basically that's about it for this specific video. So here our concept introduced is the indegree, which actually is a very important concept, though it's very fundamental. So you can actually see this concept in topological sorting, for example, in Kahn's algorithm and more. So yeah, that's basically about it. So you're welcome to follow up the videos to learn more or discuss or exchange ideas. With that said, thank you.